Hello, welcome student to our channel The Physics Point. And in this lectures we have started discussions of the new topic, that is from the part second physics, that is electrostatic. These topics we are already discussed in the previous years. The same title of topic, that is electrostatic also. In the previous lectures or in the previous years, whenever discussions of the same topic, that is electrostatic, it means firstly we are started what is the meaning or what is the title meaning of that topic, that is electrostatic. Electro, it means the charge, that is electric charge. Electro, it means the electric charge. It electric charge, study of electric charge which are under the static, it means they are under the stationary state. They are under the stationary state. It means they are can't moving or they are in the steady state. And again, we are studying the two types of the charges. One is a positive charge and another one is negative charge. The positive and negative charge we are discussed in the previous topic. They have the same name of that or same title, that is electrostatic. Then not we are not against discussions of these things, but we are discuss the remaining things in the concept of electrostatic. Now, what is the positive charge and negative charge and how they are produced in the natures? When we are friction between these two surfaces, two different surfaces, and the taken part of the friction, then they are produced these different charges, and these both charges are attracted to each other or repels to each other. When the both charges, that is plus q and minus q, the charges having the different manners or opposite manners, they get attracted to each other. When the forces or when the charges are in the same manners or the same charges get repelled to each other. Whenever we study the reflections or attraction or force in between these charges, we are discuss one of the important law. This law is named as Coulomb's law, or also we are called the unit of the charge is coulomb. The Coulomb's law, the force of attraction or repulsion between these two charges, the force of attraction or repulsion between the repulsion force, whenever the charges are same, whenever the charges will be same, the forces in between or forces experience the charges is a repulsive force. When the opposite charges are experience the force of attraction, and the magnitude of these two forces which are explained by the Coulomb's law, the magnitude of these forces is directly proportional to the magnitude of their charges, directly proportional to the product of magnitude of these charges and inversely proportional to the square of distance between them. Consider this is one charges and this is another charges. The magnitude of these charges is q1 and also q2, and the distance which we are separated from these two charges is r or d. The Coulomb's law is as similar to the law of gravitations, or Newton's law of gravitation is similar to the Coulomb's law of electrostatics. Then the force of attraction or force of repulsion is directly proportional to the magnitude of, that is q1 is the magnitude of the first charges and q2 is the magnitude of second charges. I don't know which types of the charges, positive or negative, but we just discuss what types of the forces and how amount of the forces will be experienced of these two charges. Then the distance in between these two charges or separated distance is r, and I will said before that is inversely proportional to the square of distance between these two charges. When the force will be experienced the first charge, that is q1, by the second charge which you are written like this, that is f of 2 as 1. The force experienced the second charge, first charge by the second charge, or the force experienced by the first charge by second charge, written like this. But whenever the force, how to act the force is force whenever acting on these two charges is along the radius or along the straight line joining between these two charges. This is all about the Coulomb's law. After the Coulomb's law, we are again discuss the electric dipole, how they are produced electric dipoles, and the perpendicular line electric dipole axis, equatorial axis are will be discussed in the previous years. Now, one important law will be discussed in the previous year's electrostatic topics. This law is known as Gauss law. The law which are discussed in the previous years having the same title topic, that is electrostatic. Then consider this is one of the surface, closed surface, having the number of charges. They have some number of charges in between them. Then the electric flux through the closed charges, the electric flux of that closed charges or closed surface is directly proportional to the number of charges or net charges in that closed surface. This is all about the Gauss law. It means the electric flux is equal to the net charge is Q, written as a Q, and epsilon 0 is the permittivity of free space or permittivity of the dielectric medium, not a dielectric, the permittivity of the vacuum. Epsilon 0, it is the constant of the Gauss law or constant of the proportionality, and it is also denoted by, is also called by permittivity of free space. Now, in this years or in these topics, we are first lecture starting with the help of these two laws and with the help of basic knowledge which are studied in the previous years. Now let us start discussions of the application of Gauss law. Application of Gauss law. In these headings, we are just to discuss the electric field intensity in the different shapes or different charge distribution or different spheres, different surfaces. It means the application of Gauss law. Gauss law is stated that the electric flux through the closed surface is directly proportional to the net electric charges which are present in that spheres or that closed Gaussian surface. Okay. In the first applications, we are started discussions of obtain the electric field intensity due to the uniformly charged sphere. Uniformly charged sphere. Uniformly charged, distributed. The charge will be distributed uniformly in the sphere. In this sphere, and how much amount of electric field intensity in that types of the shape or Gaussian surface. Consider a sphere having the radius is capital R. Consider this is a sphere. Consider this is a 3D sphere which have the radius is a capital R. Which have the radius is capital R. This is capital R, and we are taking about these spheres. Now, and the center of these is O. The center of that sphere is O, and which are uniformly distributed charge, which are uniformly distributed by some charges, that is Q, or only we are written like a positive charge. And the charge density, that is sigma. The charge density of that Gaussian sphere or uniformly charge distributed sphere, that is sigma, and the permittivity, the dielectric medium permittivity is K0. K0 is the constant of permittivity. This is no. The dielectric permittivity. This is the dielectric medium. The sphere is situated in the dielectric medium. The sphere having the lot of charges which are uniformly distributed hold these pairs, and also the permittivity of these dielectric medium is equal to the permittivity of the free space with the constant of permittivity. And the now total charge which are distributed over the sphere, that is also is equal to Q, the charge density into the area of that sphere. This is the area or the surface of that sphere, and also Q, it means sigma, it means the charge density. Then the total charge Q is equal to charge density into with the product of the sphere, surface of that sphere. By applying the Gauss laws, by Gauss theorem, by applying the Gauss theorem, we know that the electric flux is over a closed surface or a closed Gaussian surface is equal to the total net charges or total charges divided by permittivity of free space. This is the Gauss law. Now we want to find the electric field intensity at the tip of that point, and we call this point is a P. We want to find the electric field intensity at the point P, and the area or the smallest area which are covered by this point P is called as ds. The smallest surface at the point P is called as ds. This is the smallest cut of that Gaussian sphere. Then the distance from the center to this P, it is distance or the radius from the center to that Gaussian surface, we are written a small r. The capital R and small r both are the different. These are the whole distance, small r. And the Gaussian surface is symmetrically distributed, and the electric field intensity or electric intensity, field intensity E, is the same magnitude. It is same magnitude of the electric field intensity as like this. And again, the electric field intensity which are directed outwards along the radius capital R, which are directed outwards along the radius R. This electric field intensity E be the same magnitude and directed outwards. Just we want to find one of the angles. This R is along the capital R, the small r is along capital R, and this ds is as the same point, and the angle makes of एक और एक जरा angle असतील. These angles are theta. Theta is must be 0. Theta is must be the angle of directions. The angle of directions of ds is must be 0. Then the cos theta is equal to 1. The cos of the angle theta is equal to 1. The value of theta is 0 and cos 0 is equal to 1. This is the simplest mathematics or simplest trigonometry. Now E dot ds is equal to E dot ds into cos theta. Why I will be called the same magnitude? It means the cos theta is 1 E dot ds. This is the Gauss laws or the Gauss theorem. This is also electric flux, and this is must be also electric flux. The total, the small amount of electric flux, that is d phi. D phi is the amount of electric flux at which are situated at the surface is a ds, that is equal to total electric field intensity over a smallest surface ds. It means the electric flux at the smallest area or at the smallest surface ds is equal to total electric field intensity into ds. Now we want to find the total electric flux. Total flux. How will we find the total flux? We want to take the integrations of these two parts, LHS as well as RHS. Let's do the same thing. Phi is equal to integrations of E dot ds. E is the constant, must be taken outside. Then the phi, d phi, छोटा सा amount है d phi, तर total काढायचं असेल तर phi असणार आहे. Integrations of d phi is equal to phi, and we want to take on the outside, that is electric field, then ds. These are vector. We know that ds is the 4 pi r square, because the area of this whole area is 4 pi small r square. That is phi is equal to E into 4 pi small r square. 4 pi small r square. It means we know that according to the Gauss law, The electric flux is Q upon epsilon 0, and I will be situated in these sides. Because these equations, I will taken the equation number 2. This is equation number 2, and this is one is equation number 1. Equation number 1 and equation number 2. Whenever we are carefully observe that the LHS of the both equations will be same, it means the RHS of these two equations is must be equal. It means the capital small q net electric charges into the permittivity divided by permittivity of the free space is also is equal to electric field intensity into 4 pi r square. This is the total area of the sphere, which are taken. This is the smallest, biggest sphere, and the area of this sphere is 4 pi r square. This is small r. And now we want to take in the electric field intensity, that is E. आपल्याला काय फाइंड आउट करायचं, इलेक्ट्रिक फील्ड इंटेन्सिटी. यात असलेलं इलेक्ट्रिक फील्ड इंटेन्सिटी फाइंड आउट करायचा. त्यामुळे जे काही पार्ट रिमेनिंग आहे ते अनदर डायरेक्शन घ्यायचं. दॅट इज इलेक्ट्रिक फील्ड इंटेन्सिटी इज इक्वल टू Q अपॉन एप्सिलॉन 0 into 4 pi स्मॉल r स्क्वेअर. कारण की आपण काय करणार आहे, ऑब्टेन युनिफॉर्मली चार्ज डिस्ट्रीब्युशन्स इन द स्फिअर. असणारे जे काही युनिफॉर्मली चार्ज डिस्ट्रीब्युटेड आहे त्या स्फिअर मध्ये, त्या स्फिअरचा आपल्याला काय करायचं, इलेक्ट्रिक फील्ड इंटेन्सिटी फाइंड आउट करायचं. इलेक्ट्रिक फील्ड इंटेन्सिटी फाइंड आउट करण्यासाठी पहिल्यांदा आपल्याला जो चार्ज डेन्सिटी सिग्मा माहिती आहे, त्याचबरोबर जी काही चार्ज डेन्सिटी आहे त्याची सिग्मा आहे, आणि जो एरिया ऑफ द स्फिअर आहे हा स्मॉलेस्ट स्फिअर आपण या ठिकाणी घेतलेला आहे. एरिया ऑफ दॅट स्फिअर काय आहे या ठिकाणी 4 पाय कॅपिटल r स्क्वेअर. अँड टोटल चार्ज जो काही डिस्ट्रीब्युटेड झाला आहे तो टोटल चार्ज आहे स्मॉल q. द टोटल चार्ज इज इक्वल टू चार्ज डेन्सिटी into the area which are distributed by that charges. त्याच्यानंतर आपल्याला माहित आहे, we know that the Gauss theorem is equal to phi. Electric flux through the closed surface is equal to net charges in that closed surface divided by the permittivity of free space. And the angle of direction must be 0 because they both are the direct करतात. हा जो छोटासा ऑब्जेक्ट आहे किंवा छोटासा पॉइंट आहे, त्या ठिकाणी पॉइंटला डायरेक्ट करणारा जो काही डायरेक्शन आहे, त्याचबरोबर त्या ds सोबत असणारा अँगल हा 0 आहे. इफ द अँगल विल बी 0 देन cosine ऑफ दॅट अँगल मस्ट बी 1 because cosine of 0 is 1. After that we know that the electric flux E dot ds is equal to E dot ds dot cos theta. Cos theta is 1. E dot ds is equal to magnitude of E dot ds. Then E dot ds, it means the d phi, that is flux. Electric flux is equal to E dot ds. Now this is the smallest amount of electric flux which are present at the point of Q, and we want to find the total electric flux through the closed surface or the closed sphere. Then the total flux is equal to must be taken the integrations of these both sides, LHS as well as RHS. Then the total electric flux of the integrations of small charges is big, it is pi, and E is the constant, must be taken the integration of ds. The integrations of smallest surface is give the overall surface of that sphere, that is 4 pi r square, and the remaining part is pi is equal to E into 4 pi r square. But we want to finding this electric field intensity in that surface, and we taken one side of this which we want to find, another one is taken either sides like this. But before to taken that, this equation number 2 and equation number 1, whenever carefully observe the left hand side of these both equations are similar, then it must be know that the right hand side of these two equations must be similar. We are similarity taking this side. This is the equation number 3. And this is most important equations like star. Equation star मध्ये जेव्हा आपण बघत असाल तर चार्ज ची व्हॅल्यू दिलेली आहे सिग्मा into 4 pi capital R square. I'll be situated the value of charge in that side is equal to, that is sigma into 4 pi capital R square into epsilon 0 4 pi small r square. The similar part from the numerator and denominator must be cancelled. Then small e is equal to epsilon capital R square divided by sigma into capital R square divided by epsilon into small r square. This is the electric field intensity in the in the closed surface on the sphere which are uniformly distributed by charges. This is the first applications of Gauss law. Some special cases we are discussed in the next lectures, and just revise before the discussions of the application of Gauss law. We must know the knowledge about the Gauss law, and we must know the knowledge about the basic electrostatic which are discussed in the 11th standard physics. This is the 8th topic, electrostatic, the 12th standard physics master state board. And the first is we can be obtain the field electric intensity, electric field intensity due to the uniformly charged in the spherical shell. Thank you.